Now, to get the webinar started, here is David Pike.
Thank you, Steve. Thank you for the introduction. Hi, I'm Dave. I work for the DesignSpark team, and I'm here with Brad today to talk about the changing automotive marketplace, some of the challenges that it throws up, and how this might affect things like connected design. And first, I'm going to hand over to Brad, who's going to set the scene and give us an idea of this new automotive landscape.
Thanks, David. Good afternoon, good morning, everyone. Thank you for dedicating some time today. Today, what we really want to do is talk about some key trends that are going on within the transportation market. And these trends are really being driven by 5G. And what 5G is really doing is it's really transforming the transportation market to allow all systems within the vehicles to become connected. And what this trend does is it really drives for increased modularity. And that's really where Molex comes into play with our micro miniature product offering and focusing in developing connectors that are designed around specific needs of this market to allow for a connection between all this modularity. And it's not only going on within the car, it's going on within vehicles across the board, whether it be forklifts, bicycles, or any kind of vehicle. These systems will become connected not only internally to the vehicle, but also to the infrastructure outside, constantly communicating information, sending data, leveraging AI, and how it responds to specific environments. So these trends of modularity are really increasing focus within Molex around specific development areas. The speed is going to become more and more critical because you're driving more information between systems within the vehicle and then systems outside the vehicle. So when you're driving your car and you want to get a parking space, you'll just say parking space and options will start to become available, and you'll have pre-programmed information in to where your car will take you directly to the parking spot that's either the most convenient, the most cost-effective in that operation. That ability to do that is going to drive increased speeds, increased signal integrity between the modules that are going on within your systems. We recognize that, and we have specific development going on around getting increased features within our board-to-boards around signal integrity that are going to allow you to achieve the speed performance that you need for your applications to perform the way they need to in this environment. Looking outside of cars, you'll also have bicycles that will also have this ability to be able to detect when a car is coming into a range, or if you're coming up on a stoplight, that stoplight will be communicating to both the bicycle and the car to let them know that the signal might be changing to where the driver might be taking a right-hand turn, so that bicycle will get a notification to slow down and yield so they don't get hit by that car. All that happens in real time, so the latency between that communication has to be instantaneous. So the speed portion is going to become more and more critical, not only in your vehicles being cars, but other vehicles like bicycles, skateboards, scooters that are also going to be increasing in the roadways and various aspects of our life. The next trend is robustness. Robustness is a key trend because if you look at a forklift or a commercial vehicle or an off-road vehicle, being able to have features that allow it to handle temperature, both high temperature and low temperature, high vibration, constant vibration, are increasingly important. So we're looking at plating thickness, floating spring contacts that allow for shock absorption outside the contact area, locking features from both increased metal-to-metal friction locks and positive locking in our FPC and board-to-board and wire-to-board options. Power is also a trend out there. So what we're seeing is the need for, when power is ran to specific devices, it's becoming more intelligent. So we want to optimize our power usage into a specific device to make sure that the application is performing efficiently. So with power, one of the key trends that we are seeing is the need for it to be intelligent. So we are developing power connectors that have not only the ability to run 1 up to 10 amps of power, but also having signal connectors built into there. That way, when you're running power, you have signal connectors that are talking to active chips on the board that say, okay, I have enough power, I can now slow that power. Okay, now I need to re-engage the power to where you become intelligent about where the power is going, how much power is needed, and the device and how they're using the power to not deplete various battery systems, specifically in electrical type of vehicles. That's a huge value, and we're developing specific connectors to meet that trend that will be developing in the market. The other is environmental. So environmental is a variety of different areas. A lot of the new developments that we are coming have higher operating temps that go up to 105 and then even up to 125 in most cases. The low will be at -45, which seems to be the market standard. The other thing that we're focusing in is how we can add features to our connectors, specifically wire-to-boards and FPCs, that allow for conformal coating and potting to be used to protect the circuitry on the PCB. Because as PCBs are exposed to environmental issues, that's usually your first point of failure, is a circuitry on the printed circuit board that corrodes and that circuitry is lost due to humidity and different environmental factors that it could be subjected to. So we realize the importance of having connectors that allow you to easily coat them either through potting or conformal coating. So those are really the 4 trends that we're really focused on that are driving a lot of the new development within Molex for our board-to-board FPC and our wire-to-board products. So the next couple of slides will be over some key new products that we have recently introduced to the market that have all the 4 trends in those products that will help you address challenges that you might be seeing as more and more modularity increases within your applications. So the first one is Microlock Plus wire-to-board system. This one has a higher operating temp of 105. It has very robust mechanical locking features, but the unique thing around the Microlock Plus locking features, they're all integrated into the connector to reduce the overall profile of the connector system. So it's offered in a dual row, single row, and on the dual row, the mechanical lock is internal. So it helps, by having it internal, it decreases the overall space at which it takes up, therefore allowing you to get a very robust connector into a space savings application. The single row is flush with the housing, therefore offering the same advantages. dual contact, very robust terminal design system that is perfect for high shock and vibe or any kind of micro vibration situations. It's going to be able to handle that due to the plating and contact system. It was designed for micro vibrations and will be able to withstand the harsh environments that it might be subjected to in these specific applications. The next product is one of the more exciting boards that we have released in recent time frame, and it's called our Molex Floating Board system. It has a 0.5 millimeter float to it. As you can see in the picture, it illustrates the board-to-board interface is actually set into a spring. So that spring allows it to absorb any shock or vibration that it might be subjected to, so it does not lose contact. So if you have a high signal speed up to 6 gigahertz, this application will be perfect for that, because you'll be able to subject it to the environment. It will maintain the contact, and you will not lose any signal performance through any kind of environment that it will be going to. It has a 125 C operating temp. It has features developed that are for ease of use, with a chamfer mating guide that will help with insertion, and also locking features that will hold it in place to ensure performance. We also have a lineup of new FPC connectors that will be released that will have similar features around speed, robustness, and environmental performance with higher operating temperatures, conformal coding compliance, that will be released in the future too. So right now what we want to do is open it up to some questions that anyone might have.
That's brilliant. Thank you very much for that, Brad. I want to talk about some of the things that you've mentioned and look into one or two of the things in a bit more detail. And you've stressed the fact that these products are designed to cope with a harsh environment. Now, harsh environment could be anything from being dropped in a puddle through to the kind of vibration that you get on a vehicle, but you mentioned specifically micro vibration. Well, I'm guessing that's different from the kind of thumps and bumps you'll get with a vehicle going over the road. What does micro vibration do in terms of these products?
Yeah, perfect. So when we say micro vibration, the best example I can give you is when you're idle at a stop sign and your car is running, but there's no movement to go over bumps or potholes that are in the street. That car is still on, and there is slight vibration from the motor running idle that are very faint. And in some cases, if you don't have, for example, with our floating board-to-board system, with that mating interface being embedded into a spring, it's absorbing all those vibrations that are very faint. So what that does is it protects the terminal interface that's making contact from eroding away over time through those micro vibrations that are very intense and hitting that that mating interface area. So that's a very good question, because addressing that need long term is how we're preventing the connector from failing 5 to 10 years out due to the plating wearing away in the contact area.
Well, that's brilliant. That brings us on to the question about should we say, more commercial connectors, the kind of connectors that you'd find in a static environment in a lab or in an office or so forth. I'm guessing the kind of commercial connectors you find in those applications aren't really suitable for use in this kind of automotive environment.
So I believe you're referring to like our standard automotive connectors that are more of the connectors that are designed for exposure under the hood to harsh environment. We are going to continue to develop and deploy those connectors. That's a big focus of Molex. But with specifically in the car, as these systems become more connected and sending information back and forth, we see the need for more, we see a growing need for increased modularity. And what we mean by modularity is you look at a braking system or a transmission system. 5 years ago, those systems had no circuitry in them. They were purely mechanical. Now they have one PCB and it's growing to 2, 3 PCBs. All those PCBs will have to be connected, and they'll either be connected through a board-to-board system or a flex-to-board system. Those connectors will need to be able to withstand the environment that the car is subjected to. It will still be in a sealed system, so it won't be exposed directly to rain, sleet, snow, high humidity, but they will still be required to perform for the vibration and the heat within those systems or the cold within those systems. And that's where we're focused on as far as making sure that we have a lineup of board-to-board, wire-to-boards, and FPCs that are going to be able to connect all the growing modularity as these vehicles become more connected internally and to the outside infrastructure with the deployment of 5G.
Fantastic. That actually brings us on to a couple of questions we've had in, two different questions that are very related. Julia's asked specifically, has Molex developed any floating board-to-board connectors? And specifically, she's asking about having a tolerance on the mating angle in both directions, longitudinal and transverse, with the idea, I'm guessing the question is about, is there a bit of float that gives that flexibility? I think you've already answered that question.
Well, yeah, and it's a good question. And Molex is really focused on the floating board-to-board is a product line that we expect to develop more as we progress. So we have the initial one released, which is a 0.4 pitch, 3 millimeter height. We see opportunity to develop more height options, more feature options, but that Pacific board-to-board does have alignment features with a chamfer design that if you do mate it at an angle, it has a chamfer that will allow it to become aligned and insert properly to where it will not stub, or there's a term called terminal stubbing, which is apparent when you mate some board-to-boards together. That chamfer will help prevent that terminal stubbing through guiding it into place, making sure it's fully aligned before any contact of the terminals comes into place. So through the chamfer design and the float, those features will ensure that it's very user-friendly at any angle or position when mating the board-to-board together.
Fantastic. So it gives that user friendliness.
That addresses the question.
Yeah, I think so. Raoul's put in a similar question. It's actually related to a similar thing. He's asked specifically about using this kind of connector in a 2-layer board. I'm guessing that the design is suitable for multi-layer boards.
Yes, definitely. All these connectors are meant for multiple layer boards to have high density of signal pushed through them to optimize the signal integrity to ensure superior performance.
Fantastic. And the other thing I'm going to pick up on, you were talking specifically about these board-to-board connectors and these FPC connectors. They're generally protected inside the unit, so we're not talking about stuff that's going to be exposed to the outside world. Raoul's asked another question specifically about chemical resistance. What kind of materials are these things made of? Are they suitable for the chemicals you'd find under the hood of a car?
So, good question, and I'm going to answer this at a very high level, just to break it down. So, these connectors will not meet a lot of the automotive standard specs. So, if you look at our transportation or automotive connectors that are meant to be exposed to the chemicals and the environmentals for under the hood application, these connectors are, if you open up the hood of the car, they will be visible. They're big connectors. They have very robust mating and locking features. They're sealed connectors. They have secondary housings that help protect them from chemicals, from rain, and various other environmental aspects. The connectors that we're talking about today are not those connectors. These connectors are meant to go into systems that are completely sealed and protected from those chemicals or from that environment. So these connectors will not meet some of the automotive specifications out there that are meant for more of those harsh environments of direct exposure.
But those connectors can still play a part in modularity because we're connecting a whole series of systems together. So there's still going to be, as you say, a place for those harsh environment sealed connectors with the extra protection.
Most definitely, and then Molex is laser focused on those products and developing those products to address those. These products that we're talking about today are not those connectors. They're meant to go into the systems that will be completely sealed and connected by the more traditional transportation connectors that are offered out there.
Fantastic. I've got a question here, and this is this might be a difficult question to answer, but is there a common thread that goes through all of these connectors designed for this new generation of automotive application? Is there something that we can point at and say, this is what makes these things different?
If you look at the common, it goes back to the development trends that we're focusing on. Those 4 trends are really the common thread here. And robustness is really the first one. Making sure that we have the features in place to protect that connector interface, to be able to maintain its integrity over time, no matter the environment that it's subjected to as far as vibration and shock goes. The other trend is power. So as the applications become more efficient, how power is managed will start to progress. And then the third one is really speed. So with the deployment of 5G, as we go further along in that deployment, 5G is going to allow for it. So if you look at where Wi-Fi is at, Wi-Fi allows us to connect 100 or so different devices. 5G is going to allow us to connect thousands of devices. And 5G is going to be deployed like cellular technology. So it's going to be everywhere. So really what that allows us, what will allow us to do is everything will be talking to everything. So cars will be talking to bicycles, to scooters. Cars will be talking to traffic signals and other infrastructure property. The need to be able to quickly process data and do that efficiently will increase the need for higher performing signal integrity modularity connectors, which will be board-to-board and FPC and wire-to-board products.
Okay. Well, that's fantastic. One of the things we haven't actually mentioned yet, we've not really touched upon, is the fact that electric and hybrid vehicles are obviously becoming more common. We've got more and more manufacturers building electric vehicles, building hybrid vehicles. Lots of people are predicting the end of old-fashioned internal combustion engine cars. What trends are building in that electric vehicle market that might change how people are designing their electronic systems?
There's a lot of change there. And that specific market creates a lot of opportunities, specifically around how power is managed. With these systems running purely on batteries, you have to be efficient of how the power is being deployed. So having intelligent power connectors that are allowing not only power to be ran through the flex or power to be ran through wire-to-board applications, having signal connectors that are able to be combined into that same connector system is going to offer a lot of value in addressing that need to be able to efficiently manage the power as it's deployed.
And so you see the need to put more and more power onto and off the PCB in a way that maybe we might not have done 10 years ago.
Correct.
Okay. So apart from that, are there any other challenges that electric vehicles present? I'm guessing we're talking about things like circuit protection. We're talking about huge amounts of power, hundreds of amps sometimes. Aside from the modularity aspect, I take it you've got connectors that are there and capable of carrying this kind of current.
Yeah, Molex has developed a whole line of different power connectors that will be able to manage all the needs that will be presented as far as running a variety of different currents throughout the vehicle as we embark on more and more vehicles that are running purely off battery power.
Okay. And I've got a point here that we've talked about cars, you've mentioned bikes and scooters, but the automotive industry as a whole doesn't just include commercial domestic cars, as it were. We can talk about commercial vehicles, trucks, buses, and so forth. We're even talking about military vehicles. Do the same trends hold true for those markets as well?
Yeah, and then really, if you look at when you think about autonomous vehicles and you really look at outside of your cars, a lot of industries has already gotten to that point, specifically with military, with drones. But also, if you look at our warehouses, forklifts are becoming more and more independent, to where we're probably a year, 2 years out of having completely autonomous forklift and or inventory management vehicles that are going and getting inventory within and managing inventory within a warehouse system. So what that will present is increased sensors, increased AI, which is increasing the amount of active components that are going into these vehicles that are able to process the information. That will continue to drive the need for all the development areas that we're focused on to help connect that modularity to allow those systems to perform efficiently and effectively. The other thing that this is going to create is a lot of opportunity for us to address infrastructure deployment that helps define the fields at which these vehicles will operate in. And those same development needs will also go into those applications as they're deployed.
Okay. Actually, that then leads on to a question we've had specifically that talks about these automotive connectors, and some of the features they've got are fantastic. They're robust, they're reliable, they allow high speeds, they can cope with a range of temperatures and environments. I'm guessing that this is starting to blur the lines between the automotive market and the industrial market. I'm guessing industrial designers can actually take advantage of some of these technologies as well.
Yeah, they're going to be able to do unique and creative things with these technologies, specifically with a low-profile system. Will give them the space and flexibility to design their systems according to the needs that they have to address into their customers. So being able to have that flexibility through the trends that we have discussed is really going to allow them to do unique things within those applications.
Okay. And looking at the automotive world, are there any standards that people need to be looking at? I'm guessing that there are plenty of standards for, should we say, the older generation of automotive connectors that we talked about earlier, the waterproof ones, the ones that live under the hood that have to cope with these environments. Are there any standards in place that people need to be thinking of when they're thinking about this new generation of connectors yet?
There's always going to be standards that we need to think about, and within this particular market, there are several standards. We are looking at those, and kind of like we addressed in some previous questions, is these connectors that we're talking about today are going into sealed systems. So we will address some of them, but there will be some standards that we just won't meet, because they won't be applicable to the connection points that we are really going after with these developments. But we have teams that are dedicated to understanding these standards, understanding how we can adapt them into our development, to making sure that we are getting the best product out to add value to the design engineers that are using those for the specific applications that we are looking at.
Okay. And actually that leads me on to a question that Carlos has asked, and this is kind of tricky because it comes to the very heart of the Molex offer. What Carlos has said is that Molex offers a large variety of options, and it can be tricky to actually decide and choose between one product and another. Can be a bit confusing. Where's the best place that engineers and customers can come and find the information they need to start specifying the products?
So and this is going to sound generic, but the best way to find information is Molex.com. All the information on the products that we discussed, as far as the newly released products, can be found on Molex.com. They can be found very easily, to where if you go to product families and then go to wire to board and then to signal, you'll find all the micro wire to board products, specifically the Microlock Plus in that area. And to find information about the floating board to board, you can go to the search feature, type in FSB5, and be able to pull up information on that connector. Or you can go to products, go to board to boards, and then to signal board to boards, and then you'll have access to all the information there.
Fantastic. And I take it you've got the opportunity to chat to engineers as well at Molex. So certainly I've always found it fairly great being able to talk to the guys at Molex who actually know about these products and are specifying them every day. So to Carlos and to any other customers out there, I would urge, go to the website first, have a look for the information, but don't be afraid to ask. If something's confusing, something's not very clear, Molex do know their stuff. It's please, by all means, persevere, find the right person to ask the question, and I'm sure you'll find the product you need. I think we're coming to the end of the questions that we've had submitted. I found that fascinating. The automotive market is, I mean, it's huge, isn't it? There are millions and millions of vehicles being made every year, and the vehicles are getting smarter. They are being packed with technology, and we still leave our house every morning, turn the car on, and we expect it to work every single time. So that combination of the amount of features that are going into these vehicles, the reliability that we demand of these vehicles, and we rely upon them to get us from one place to another, means that it's not just the electronics, it's the hardware, and all the connectivity has got to step up and keep going in pace with things like the 5G technology and all this connectivity. We're talking towards autonomous vehicles where people can, to a certain extent, sit back and let the car do some of the work. But at the same time, we need to be very aware that this technology is potentially dangerous. We need to make sure that everything works perfectly. So I'm going to say thank you to Brad for all of that information. I've certainly found it absolutely brilliant. If there are any more questions, by all means, we'll field them. But I'm going to hand back to Steve now.
All right. Thank you, Brad and David. On behalf of DesignSpark and Molex, thank you for joining us. Take care and have a great rest of your day.